Good day and welcome. This is Arsenic Natapov, 9591222, Team 6, and this is a project for Comp 3721, computer graphics at Concordia. So if you're watching this video and you're not the teacher or the TA or someone I have actually referred to it, go away. So yeah, this is the revised version of the application called Awesome Pac-Man, whatever. Yeah, I'm actually going to review the final version right now and all the additional features that we added. So let me go through the ones I've discussed in the demo before, as I actually forgot to mention some things. So this is called deferred rendering, in the sense that it first computes the diffuse colors and then the lighting separately, which basically allows for any number of dynamic lights in the scene. As you can actually see, in this case there are 6 of them, and you can actually see that there are many shadows overlapping, going on the walls here, going on the cloth. It really does not see the difference between meshes. So this is the first stage of the rendering process, computing diffuse colors. This is also the step where the environment mapping is being computed. As you can actually see, I can tweak and put this into like some kind of glossy chrome-like state. This is called diffuse factor, so I actually blend the environment mapping with the diffuse texture. Then after this step is done, which is basically quite simple, the light mapping is being computed. Here, this is a two-step process, two pass. Well, the first pass computes the shadow map, which is not shown here, but you can actually see it by all the shadows in the scene. It just places a camera at the origin of the light, facing the direction, and takes basically a screenshot, I guess. Then it is used for computing the actual lights. So if it's as with the shadow mapping algorithm, if it is the pixel is blocked, it is not lit. If it's not blocked, then you apply funk shading to it. As you can actually see, there's also already bump mapping applied to the object, and as you can actually see, it applies regardless of there being it being a cloth or like a reflected texture or whatever. So that's actually the advantage of deferred rendering, because it really does not see any difference between any types of meshes and any types of surfaces and any types of textures. So yeah, as you can actually see, this there's actually 2 maps being computed. There was no original reason for this. I think the decision of breaking into the 2 maps, the light map and the specular map, has been taken in the process where we did not exactly understand how the deferred rendering was going to work, because the whole algorithm was actually derived from 0. We did not use any white papers, and frankly, we didn't even know that the word was deferred rendering. We found out like a month later when going through some samples. So, but it does actually allow us for this pretty cool effect. Yeah, so this effect actually is just it doesn't change anything here, as you can actually see, but it actually does change this map. So yeah, so it actually does not. It stops clearing the map at some point, and for the and that actually yields this effect. So we did not actually exactly know how to implement it in gameplay. We thought maybe like when this Pac-Man speeds up, we could actually make it look like this, but there is, as always, there is no full implemented gameplay, so we did not bother with it. Yeah, as you can actually see, there's one thing I forgot to mention during the demo, is that all the what are called, all the normals and all the binormals and all the actual what's her name, and and all the tangents are actually computed by automatically when we are importing the mesh. So those, as you can actually see, the red ones are the normals, the green ones and the blue ones are tangents by tangents, and they are actually used for bump mapping. So like more, it's a simple algorithm. It's just like used for rotation, but yeah. So we had to actually compute those while importing the mesh as well. So this is the final. So as you can actually see, uh, this is the diffuse, light, specular. Then it's all blended together according to the formula discussed in the documentation. So this is the final image. Okay, so basically, yeah, that's the whole deferred rendering process. Then the bloom is being applied. The bloom is actually it's a photographic effect where the brightest spots appear to be leaking over darker spots. So in the end, it looks like this. So you can actually see the difference. And the way to achieve this is basically we take this image, then we cut out all the black spots, like this. So you can actually see, we can actually control how much black we cut out. So yeah, let's leave it at the original value. And okay, let's see, this is good. So this is called the light pass. It actually removes all the darker spots from the scene, and we're going to use it for our bloom. If we do not use the light pass, so as you can actually see, this is the bloom, the final bloom image. If we do not use the light pass, then it's not called bloom, it's called glow, and this is the final effect. So as you can actually see, everything seems brighter. It looks cool, but it doesn't look exactly realistic. So we actually use a light pass to, to control the bloom a little bit more. So yeah, back to the light pass. This is the one, but now we actually need to make it leak through the edges. So how we do that is we actually blur the image. And when we blur it, there is some brighter spots which actually begin to actually go over the dark, the black that you can actually see here. So first, to do that, we actually downsample. So we shrink the image 16 times. You do not see the exact shrinkage here. Why? Because we basically, we shrink it and then we stretch it back over the screen, but you can clearly see that it's very blurry and that it really looks like an image which has been stretched over a surface which is like many times bigger than it, and in this case it's 16 times. So yeah, as you can actually see, it already leaks over. So yeah, it's less sharp, so we could already use that for bloom, but the problem is that the quality of the image is very, very poor. So as you can actually see, it's pixelated. So and it really will look very, very blocky and unnatural. So what we do in this case is that we apply Gaussian blur to it, and it's so you can actually see it a little bit here. So this is the downsampled image, and this is the blurred image, and the blurred image actually, yeah. You can very barely see it in this case, but the blurred image looks actually much better. Well, not much better, just a little bit better, more acceptable in this case. So yeah, and then we just add this image on top of that image and multiply it by some variable which is called diffuse factor, and it yields this. The diffuse factor can be controlled. So right now it's at 0.8, I think. The starting thing, you can actually boost it, so it makes it look like this. Really, really like stupid. You can actually, when you move it around, it's like, nah, what the hell is that? So yeah, we can actually tune it down. We can even make it go, negative. This looks pretty stupid as well. It's like the lightest spots are actually, going away. So yeah, and that's the whole. Yes, that's our whole graphics pipeline. So that's all for our graphics features. Yeah, right now you can actually see that the shadows are much better than the ones in the presented during the demo. That's because we use a 4 times bigger shadow map. So before it was actually, the resolution was 1 megabyte by 1 megabyte, 1000 by 1000 pixels. Now it's 2000 by 2000. So basically, And yeah, the performance lags suffers because of that. Plus, I'm running fraps and recording the video at the same time. But yeah, have to make sacrifices. So yeah, it looks much better in this case. Also, yeah, that's about it for the graphics. The only thing really that I forgot to mention is this thing. So yeah. Now for the actual, for the actual gameplay. We have implemented eating. No, actually, eating will be discussed later. We have implemented AI. So as you can actually see, the ghost here is, is waiting right now. So it actually has the troll face on, as discussed in the document write-up. So when it has the troll face, it's actually waiting. So you can actually see it will wait for about 3 seconds and then starts moving. When it starts moving, it has the Megusta face. You can actually see it clearer here. So I'll actually show it in the diffuse. So in diffuse mode, so it's actually much easier to spot. So here, see, it's waiting. Then it's roaming, waiting, roaming, waiting. This is the roaming stage. So now I can actually try to approach it. See, it actually became a rage face. So this is actually attacking mode. It actually pushes me, so I'm actually going to try to escape it. And as you can actually see, once you go out of its reach, it returns back with sad face on it, which is quite frankly very hard to spot, because yeah, oh god. Yeah, well, you can actually see it in the because it's because of a cloth. It's quite kind of convoluted and it's moving at very fast speed. So oh, here it is. Yeah, okay. So yeah, but it's better seen in the screenshots presented in a write-up. So as you can actually see, there is AI. This thing is moving around, trying to attack you. You know. So and yeah, now you can actually eat pellets. So if you actually see, this pellet is here. Once I'm going to touch it, it's going to disappear. So it's not there anymore. And you can actually eat. Oh god. You can actually eat pellets here. It doesn't give you. It gives you points, but there's no HUD exactly. And yeah, frankly, we just because there's no gameplay, so there's no real reason for us to actually put anything additional to actually make it like more, more motivational or anything. Because this is really a graphics project, and if it comes to graphics, we actually really did succeed. So, but yeah, you can eat pellets, and yeah, they basically you can actually think that they just don't do anything. But yeah, so we have AI, we have the physics. As you can actually see, the movement is a bit jittery. That's because the clothing is actually, it's draping behind. It's actually hitting the plane, and therefore actually stopping the Pac-Man from rolling properly. But yeah, so also as you can actually see, we added yeah, like we can find the box here. So and frankly, yeah. So this is the uh, this is quite this is actually it. So this is the I guess this is the demo, and yeah. Is there anything else to say? No, actually everything else is in the write-up. So yeah. It everything else has been discussed there. So as you see, they actually discuss the framework, the architecture, and thank you for watching.